So I'll be talking about like networking, packets, and like kind of pulling data out of that. So the plan, we're gonna get a bunch of data from a network, we're gonna read that data, we're gonna kind of just do things to it, and then we'll hopefully learn something about like a protocol or something that's going down your stream. Kind of like basic background information, like network layers. I'm sure you guys have seen all this stuff before, but there's like the OSI models, like you've got 7 like layers in networks. You've got the physical, literally the physical stuff. The data lake layer, not really something most of us like kind of think about, but it's like error correction and detection for the physical layer. Network, IP addresses. We're getting into like more familiar territory now. Transport's more like TCP and UDP, so your usual transport layer, the stuff that transports stuff. Sessions controls like connections between computers. Presentations, kind of weird. Don't really have a good explanation for it, but the way I kind of see it is that like it's like packing of data structures. And the last one's applications, which is the stuff you see. Get on your phone, all that stuff. That's your application layer. So for us, like we're going to care about 1, 3, 4, and 6. Because physical access is always good. Network and transport layers are very, very kind of like easy to work with. And the presentation layer is kind of where like a lot of your specialized packets are, where if you actually know what you're looking for, it saves you a lot of time. But like more background, physical hardware. This is a switch. You guys know what switches are? Cool. Basically, one port to many ports in terms of like redirecting traffic. Routers kind of look like switches, except they also basically generate like, they basically also, the way I kind of see it is that routers will also designate IP addresses and manage the network on top as well. Wireless access points, Wi-Fi. What we usually call routers are like a combination of all 3, honestly. More background, TCP, UDP. TCP is like one of the protocol that's basically you try to send stuff over and you try to get an ACK back. And then every time someone talks about this, they bring up the general's problem. Because how do you really know if your ACK's been like accepted except to send like ACKs forever? Whereas UDP doesn't really try. UDP just sends and it just kind of just hopes it gets there. Different things for different use cases. Another like little thing to kind of like know about multicast versus unicast for like UDP. Unicast is basically just single streams. So every time you have a single stream, you just send a single stream. It's all 1-to-1, one sender, one receiver. Multicast, you have one sender, multiple receivers. It's a really nice thing that you can get on a network that helps you snoop. Cool. Wow, I did not. All right, cool. Damn, there's a lot of background I put in here. All right, another thing. So like everything here is like packets, right? Like your typical packet will have like your level 2, and then inside of that you've got like your level 3 stuff, and then inside of that you've got your level 4 stuff. Inside of that you've got like your 5 to 7 stuff. And it's all just like layers and layers and layers and layers. And like usually when you like take a look at these packets, you'll see like a lot of stuff like the same. It's like, oh, it's coming from this address, this IP going to this IP. Well, this address going to this, from this IP going to this IP, using this protocol, controlling, like holding this data. It's kind of like how it looks. So it's a data turducken. Yeah, it's just layers and layers and layers. So like a normal network that like you'd see at home is kind of like this, right? Like you'd have your wireless router, you'd have a couple wireless devices, maybe you have wired devices. I do, because I'm weird. And then like a slightly more complex network is that you throw a couple switches in there, and then you've got like some weirdness in between. Slightly complex, more complex networks are harder to snoop at the end of the day because you have to kind of get into the right spot for a lot of this stuff. So like how do you grab that, how do you ultimately like grab data? If it's multicast, it can be a lot easier. You just directly hook it up to the switch, and then you just pull that stream in because it's being multicasted. If you're lucky and if you're on like a fancy network, there's like a few managed switches that'll let you like duplicate data. So say there's like a TCP IP stream that jumps from this guy to this guy. So it'll jump through this port, this switch, this switch, this switch over to here. And if you can get a little duplicate stream here, you can have all that data also duplicated to here, and then you can like suck it all up. It's pretty useful. Makes everything a lot easier when you can get everything duplicated and just delivered to your doorstep. This is kind of more like, so spoofing your IP versus like ARP is kind of attacking like the level 3 layer a little bit. Whereas, so what happens is that someone with like a specific MAC will ask for like, all right, who has this address? And then you kind of, the network kind of just trusts only one device to send back like, I'm this address at this MAC address. What you could do is that you can have your device just say, I am everyone, send it all to me, and then I'll route it from there. And that's how you get in between there. But the easiest way to do this is just to own the routers and own the switches. So if you've got like a DDWRT setup on your router, everything has to go through that, right? Just dump it there. Yeah, what am I doing today? None of these things. I'm cheating. I'm going to use my computer's loopback. Mostly because I kind of thought this through and like I tried to be ambitious. Like I'll bring a couple devices. I'll bring like a couple like IoT devices that like I know are like pretty weak. Yeah, time ran out. Cool. All right, so tools of trade. In this case, like when it comes to this, it's Wireshark and tcpdump to a certain extent. You can run tcpdump in the background, but it's a lot easier to kind of view that data through Wireshark at the end of the day. Yeah, and like kind of like when you go through stuff and view it through Wireshark, like you'll see stuff like you'll see the headers get broken out. So like an IP header, you'll see like all the packets for this stuff. Not as color coded, but Wireshark will break it out into its own specific little spaces, so you don't even need to remember this stuff. TCP, kind of the same thing. You know, it'll break it apart into like its specific parts. UDP, UDP is the easy one. All right, cool. Where's my stuff? All right, cool. All right, so quick demonstration. All right, so like let's get inside some like UDP data. So I've got like a simple little like receive server here that's just sending a message and repeating it back. It's on the loopback, so let's see if we can find it. Yep, this is the message. It will be repeated. There's like also your headers and stuff, but tools make it easy. It's like you don't even need to know the packet structure for the most part.
Is this like all the packets on your local network?
Yeah. Okay. So part of the reason I actually decided not to use like a live network is that I noticed that like I really tried to shut down all of the services that were broadcasting on my Mac. Just couldn't do it. Yeah, it's like way crazier to look at something like that. I could show you later. Okay, so both of these cases are like fairly basic because the way like data is getting sent is that it's over like it's just straight ASCII. So yeah, like you usually won't wait. There it is. Hello world. So you usually won't like see data in this format, but you'd be surprised. Like a decent amount of code from like 10 years back will just transfer data over like TCP/IP pipes like this, and if you like jump in the middle, you'll find like XML files just being like passed around like so. It's pretty sweet because you get to know what it is too, and read it as well. Yes, I think. Command plus. Cool. Cool, awesome. Okay, so like inspecting like raw TCP UDP is kind of straightforward, kind of not, because like this is the ideal situation. UDP is a little easier because usually UDP messages won't have like multiple parts, whereas TCP like streams will come in streams. So you'll have like tons of packets coming in at a time, and then kind of like making sense of that is what's kind of tricky. The nice thing about it is that almost no data is in like raw TCP or UDP these days. We've got great protocols out there like OSC, 0MQ, HTTP, which I'm sure everybody loves. WebSockets, which is kind of like a way to like try to bring a TCP socket onto like the web layer. SSH, FTP, ArtNet, all of these guys are basically really nice like level 6 protocols that structure the data up so it's incredibly easy to send and receive amongst like different clients. The nice thing about that is that they have set structures. So we can totally just backtrack like exactly what they're sending out with that. So OSC, right? OSC has 3 parts. It has an address, data tags. Usually these 4, I've seen more as well. It kind of depends on the OSC library you use, and data. And the way it's structured, it's literally just that. You have your bytes for your address, then you have your bytes for a data tag, and then you have your bytes for the data. That's it. It's just like right next to each other. Cool. All right, so I'm sending a slash filter as my address. I'm sending 4 like things along the pipe. In this case, it's a float, an int, a string, and a byte. And in this case, the float is this number. I think it's random. I believe it is random. There's a random float. Yeah, it's random. This is like the int being sent down, and then hello, galactic, string, and blob. And the way to kind of like see this out is that the tags will usually be like within like a set of bytes, within a set of like 8 like units here, and then like floats will be 32 bits, ints will be 32 bits, strings will be null terminated. And then this is interesting in that, so blobs, at least for OSC, you have to like set the size of the blob beforehand. So you get like an int first with a number, and then the rest will be the number of blobs. But yeah, if you kind of know like how like OSC is packed up, it's pretty easy to like just grab like everything you have off your network and then just watch it go. So if you've got a couple devices on your network communicating to themselves over OSC, grab those addresses and take control. So the raw way is one way of doing it, but there's a better way. 0MQ is like a little bit more complex, so let's use a Wireshark plugin this time around. This one. Cool. So the nice thing is that like a lot of people have built out, oh, whoops, I gotta stop it's gonna get confusing. All right, cool. So the nice thing about like Wireshark is that people have built in tons of plugins. So packets are kind of like structured and set, right? So why not just build something that can pull them out? So if you, cool. So like for a lot of like these level 6 protocols, you should be able to. They're either like preloaded into Wireshark, or you can download like plugins that'll help you go through and just it'll detect like what kind of packet it is, usually based on the headers, and then just break it down. So in this case, it's able to figure out, okay, data 5 bytes, this is it, and it's the hello. And like with more complex like 0MQ like transmissions, it helps figure that. It helps like basically break it down so you're not like going byte by byte and dealing with that. The trickier part with like I'd say like a bunch of like level 6 like protocols is that you've got these variable data sizes. So you usually hit like a part where it's like, okay, this is your data size field, or like this is kind of like how it's supposed to be packed. And remembering all that can be a bit of a pain. Whereas this will just let you be dangerous like immediately as a beginner. Okay, so WebSockets, WebSockets I kind of find like are actually really interesting because it's an example of like the web world trying to like basically go lower level. And there's like a lot of examples of this doing that, but especially here it's just it's essentially just a TCP socket under another name. The way like you start up a WebSocket is that it's you have a regular HTTP request, then you send an upgrade request to the server to change it into a WebSocket, and then it changes into a TCP connection. Yeah, and it's like really low, overhead too. So like this looks pretty humongous, but this is optional, this is optional, this is optional, this is optional. All you really have are the 2 bytes in the front. There's also going to be a little bit in that, but it's incredibly like low. It's for like sending data across like the web. Like this is a really small header compared to like your HTTP like headers. Wait. Allow. All right. Cool. Yeah. So, oh, I wasn't recording, was I? All right. Dang it. Where's the? There it is. Let's try that again. Okay. So this is a case where like it's kind of like a TCP packet, but it's also kind of like, wait, what the? I didn't send that. Not again. Third time's the charm. All right. So in here, we will find some frame that has like that sent. I see my 0MQ still running, so that's not good. Cool. Yeah. And so like it's all like easier when it's kind of ASCII in this case, but the same ideas kind of apply like when you're sending data like back and forth. When you're sending like data back and forth, especially if it's JSON, you should be able to just grab the blob and then either they send it as raw as like ASCII JSON, not recommended, still happens, or as like byte JSON, grab it, throw it into like a library, comes out. Like there's an interesting way to get data out of this. And WebSockets I think are probably interesting long term, just because like, I don't know, I find that more and more things on the web are trying to like spy on me using WebSockets. So I figured it's a good one to know how to like snoop. So like this is like all like level 6 snooping, right? It kind of allows you to like reverse engineer APIs that are built on top of a specific protocol. And honestly, I feel like that's kind of where like a lot of like power comes from, because at the end of the day, like as engineers, we are all pretty lazy. I don't really want to rewrite a protocol when there's OSC. But like the downside of that is that there are cases where you'll kind of want to like get lower level in that. Like snooping at the level 4 level is pretty much the same thing, except much worse. Because you don't, because like ultimately what you're doing is that you collect a lot of data packets, you inspect them like using the hex data field, so you know like what the data field is of your TCP or UDP packet, and you just kind of try to figure out the structure. Sometimes it's easy. So if they're all fixed length, it becomes a lot easier because you're probably dealing with like a single struct that's being sent over and over and over again. If there's like magic words like I don't know, 80, 80, 80 as like an aligning feature, like you should be able to line those up like pretty straightforward. And there's like also other things that you can kind of take like advantage of. Like floats will look way different than ints, and floats will have like probabilistically will be in a certain arrangement. Strings will look different from like ints as well. Like just kind of going down those lines. Yeah. Ultimately, like all this stuff is like, that's like all like if you run into issues, like going lower level is usually the answer if you want to like figure this stuff out. So like even though like there's like known implementations for like all these like protocols, you might run into like some weird structs over TCP, you might run into some weird JSON over TCP, and I keep running into these custom like lightweight control and marshalling implementations just because of the industry I work in. And nobody ever documents that stuff. So yeah, have fun crowbarring stuff. So like an exit note on this stuff is that ultimately like encryption is your enemy here. 0MQ, HTTP, WebSockets, SSH, FTP, all of these, if you get SSL like encryption on top and you miss the handshake, you're basically not going to be able to get all the data out of it. Whereas OSC, ArtNet, a bunch of this other stuff, they don't really usually implement encryption on top. So the annoying thing with this is that you can't really exactly tell what the data itself is or like the data size usually, depending on how it's schemed out. But it is kind of useful to know like the frequency of messages, senders, receivers. Like if your smart TV keeps pinging Samsung, you know the drill. Unplug that sucker. Yeah, so like metadata still has value, as our neighbors 2 blocks down the road definitely know. Yeah, cool. Any questions and stuff? That's like my last slide. Yeah.
Can you talk a little bit more about the encryption in terms of what does and doesn't work? I guess it's just about capturing the handshake and then you're good to go, and Wireshark takes care of the rest? Or?
Depends. So like it depends on the encryption scheme, and ultimately that's an encryption that's an encryption talk. I'd say if you can capture the handshake, you are more liable to get stuff. If it's like elliptical key, like good luck. Yeah, it just really just depends on the implementation of like what you're dealing with there. And ultimately, I find that it's usually like a binary case where like either there's a library for you to deal with that situation that's already built, because someone else definitely knows this stuff better than you or I, or there's no library and you're kind of just out in the cold.
Say you have control over the router, then in that case, can you break the encryption of like these protocols?
So that's the whole point of having like good encryption, right? Like you're not supposed, like if you have like good public key encryption where you have a secret already saved, presumably like even having a man in the middle you can't really deal with that. Yeah. And like honestly, like some of these protocols will deal with that and some of them won't. It just kind of depends on implementation. Yeah. I am not a security expert, guys.
So if you decipher some APIs, can you give some examples of things you can do?
So I kind of find that like, so one thing I kind of had to do for work is that like 3 weeks ago, I was given this tracking system, this full like tracking system, and they sent over 0 documentation. And what they really, really wanted us to do was buy their Windows front end. Yeah, so I'm pissed at like 3 levels. Well, oh, my bad. I left out the part where the Windows front end was a GUI, so I can't even automate it. I have to park a person there in order to make this stuff work. Like, if I want to deploy this out in the field, hell no. So yeah, like I mean, it's kind of hidden cases where like I personally find that like when you're trying to buy stuff that has specific vendor lock-in, and they try to enforce that through software on both sides, cutting in the middle helps out a lot. For this stuff. Also, you can do dumb stuff like you can get one of those like dash buttons and just capture it in the middle and then make it do other things without even having to open it up. That's also cool. I did not pay for their front end. Cool.